Hello, it's Mr. Zabo again, and this is the last video for the first day of notes in Chapter 11. In this video, we are going to talk about the range of data, the quartiles, which would lead us to interquartile range in a box and whisker plot. So what is the range? It's the maximum value minus the minimum value. So it's the difference between the biggest value and the lowest value. Quartiles, we're going to call them Q1, Q2, Q3. Divide the data into 4 parts. So you'll have the first part before the first quartile, or Q1, the part in between Q1 and Q2, in between Q2 and Q3, and then after Q3. You're going to have 1, 2, 3, 4 parts. Therefore, the interquartile range, which we will visualize and see in a little bit, is Q3 minus Q1. Similar to max and min, or max minus min for the range, but now I'm not going to take the extreme values. I'm going to look at some of the values inside. And the box and whisker plot is a way that we can display all of that data in something a lot more visual, and it uses the median as a measure of central tendency. The median is going to be Q2. Oops. Fix that. Q2 is always going to be the median, so the second quartile is your median. So what a box and whisker plot looks like is we're going to put a box around all the data between the first and third quartile, and then have these whiskers that stick out of the box that represent your maximum and your minimum values. So let's take a quick peek at what that looks like. In this data set, it's already numbered from low to high, so it should make it easier for us to identify our quartiles. It's typically, you always want to start at Q2, which is going to be your median. So when we look at the data set up here, it's in order. We can take out our maximums, and we can get right down to the middle set, or the middle number, which is 34. That's Q2. That divides this into 2 sections. What we now want to do, 34 is Q2, is find the first quartile, or Q1. To do that, we're going to focus our attention solely on this information here, the first part, or the lower half of the data. And essentially, I'm going to do this for now, is ignore Q2 and beyond, and the upper side, and look for just at this data, what's its median. 27 is the median of the first quartile, or of the first part of this data. That's Q1. And then we do the same idea to find Q2, or Q3 I should say, is ignore the first half of the data and look at the upper half and see that 50 is the median of the upper half. That's our Q3. So we have a Q1 at 27 and a Q3 at 50 with this data set. Now I have 1, 2, 3, 4 sections. Then the maximum and the minimum values are going to be your extremes. The minimum value is 20, the maximum value is 86. So I'm going to list those just so we have them all listed. Finally, constructing the actual box and whisker. And this is not always going to be provided for you. We might provide a horizontal line for you, but the key is you want to sketch this below, but you have to label the axis, putting a title on your graph. So we'll do the title and later, but the labeling of the axis is the 20, 30, 40, 60, all the way up to 90 in this case. You have to figure out where to do that. To do that, you look at what is your minimum value. So you know you need to get to at least 20. What's your maximum value? We have to get to at least 86. So on here, we ticked off and we marked all the way until 90. Now we go through and we construct this. We draw a box from Q1 to Q3. Q1 is at 27 and Q3 is at 50. So I'm going to go on to my box and whisker plot, and at 27, so here's 25, I'm going to go a little bit beyond 25 to 27, put a vertical line, go to 50, put a vertical line, and essentially I'm creating my box there. That is representing where all of the data is in the middle quartiles. Now, I'm going to take Q2 and just list it in the middle of my box at its location, 34, with another vertical line. So it's not always going to be smack in the middle. It's just going to be inside the box. It can be anywhere inside the box. Last, I'm going to graph, just plot 20 and 86, my minimum with a point and my maximum with a point, and draw the whisker all the way out to those. So the box and whisker plot is representing all of the information in between the minimum and the maximum with half of the data in that box. The range of the data above is the max minus the min. That's the 86 minus the 20. So it's 66 is the range. And what it's saying is that there are 66 is the variation in the number of surgeries, or it's the spread, because we didn't put a title on this, which we should have. It's the number of knee surgeries performed by 15 doctors, or by 15 doctors. You want it to be a fairly specific name for your title or for your graph. The range being 66 means that this is a very spread out data set. Because there are a difference of 66 surgeries between the doctor who did the least and the doctor who did the most. The next question asks to find the interquartile range, or the IQR for short. To find the interquartile range, you take Q3 minus Q1. So in this case, Q3 was 50 and Q1 was 27. I'm going to take 50 minus 27 and find that the IQR is 23. What does this tell us about the number of knee surgeries performed? In this case, it means that 50% of the doctors, the middle 50% of the doctors, only had a variation of 23 surgeries. This is significantly less than the range of 66. So total number of doctors, all 15 doctors, if we look at all of them, there's a range of 66 surgeries, which is pretty significant. But if we look at just the middle 50%, the range is only 23, which is far less significant than the 66. So why is it beneficial to publish the range and the interquartile range instead of just giving the median number? Well, as a consumer, it's important to know the range because it tells you, that overall difference in the performance. But the interquartile range allows you to focus in on just the middle 50%. So there's a few different ways to look at this, though, as well. If you want to know the doctor who did the most surgeries, they might have a better success rate. The least number of surgeries, they might not be as skilled or as experienced. So you might want to consider looking at success rates as well if you're doing actual shopping for surgeries. And finally, the last concept I want us to be able to go through is percentiles. These are the numbers that appear on your standardized tests quite a bit. So as you're taking an SAT or an ACT test, oftentimes it'll come back and say that you are in the, for example, 78th percentile or the 85th percentile. What that means, or I should say what that does not mean, it does not mean that you got 78% of the questions right, or 85% of the questions right. It's not a percent of accuracy. What it means is the value, or it shows the percent of the data that are less than or equal to that number. So if you were in the 78th percentile, it means you scored better than or equal to 78% of all people who took that test. So the 78th percentile, you could have got a 42% on the test, but 78% of the people scored that or less than you. So if the weight of an infant is in the 78th percentile, what does that mean? Go ahead, press pause, and try to come up with that. Okay? So it means that 78% of all infants weigh less than or equal to this infant. And that's the important thing to recognize, is that could be exactly the same and still be considered the 78th percentile. Okay? With that said, give the 85th percentile on the planned test score a try. Okay? So it means you scored the same as or higher than 85% of all test takers. You might have got a 40% on the test. You might have got a 95% on the test. Doesn't say anything about accuracy. It just compares you to all other test takers. So if we're actually looking at an ordered list of, say, infants and weights in 1 year checkup, what value is at the 65th percentile? To figure that out, we need to figure out, first and foremost, how many values there are in total. So we have 3, 6, 9, 12, 15, 18, 20 total values. So to finish in the 65th percentile, we would calculate that by taking the 20 values times the 65%, which would be 0.65. Okay. When we do that, we get 13. That means the 13 values need to fall at or below your infant's weight. So since these are in order from left to right and then over, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 13th term in this set of data is 23.5. So the 13 values fall at or below 23.5. So that's the value of the 65th percentile.